So, good morning, student. So, I welcome you in the lecture number 9 of micro engineering subject. So, in this lecture, just a minute. Just I will take pen. I will choose color. Okay. So, good morning, all of you. So, in this lecture, I will discuss about the GUNN diode. GUNN diode, its working and its application, and its construction. Also, we will see in this lecture. So, Uh, if you are not still you are not subscribed my channel, please subscribe the channel. If you are subscribed, then you are getting the every update of my video which I have uploaded on my YouTube channel. So if you want to see the entire lecture series of micro engineering, so go to playlist and watch the entire series of whatever the lectures I have taken. Likewise, you can enjoy the lectures of EDC also, and you can enjoy the lectures of DFT also. That is nothing. Discrete time signal processing subject, so whichever I am dealing. Okay, so we'll revise first what we have seen in the last lecture. We have started with the GUNN diode, sorry, pin diode. That is nothing the P-type material, then intrinsic layer, and is N-type material. If you sandwich this intrinsic in between P and N, so whatever the resultant diode is called as PIN. So this structure is like this one. Structure is like this one. So here P material is there, P-type semiconductor material is there. Here you will find N-type material, and here you will find the intrinsic layer. So this will act as a capacitor. This will act as a capacitor because this is also conductor, which is having holes as majority carriers and electrons are the minority charge carrier. And here N-type material, electrons are the majority and holes are the minority. So in the intrinsic layer, you will not find any kind of majority and minority. Whatever the charge carrier holes are there, same carriers are electrons are also there, so it will cancel out, and what will happen, nothing is majority, nothing is minority, so it's why it is act as a pure semiconductor, so it won't conduct anything, it won't conduct anything. So it act as a insulator, it act as a dielectric material in between this. So this will act as a capacitor. We have discussed in the last lecture. If you have not seen the last lecture, please go through it. Okay, this will act as a capacitor, whichever I am drawing over here. Yeah. Okay, so this is the construction. So this is the metal contact we are taking out from these two terminals, that is anode and cathode. After that, one diffusion layer is there, then intrinsic layer is there, then N-type material is there, and N plus contact is there. Okay, so you know that P and P plus. So this P plus indicate that it is having more holes than the P1. Okay, likewise you will find P minus. Okay, it indicates that whatever the holes are there that are less than the whatever the standards we are having at all. And here we are having the more concentration of holes, that is nothing but we are adding what, boron, indium and gallium, more concentrated we are having. Okay, so this is nothing but the p-type or n-type junction over there, and the diffusion layer is nothing but what, the whatever the holes are there that will diffuse in this layer, so that is called as diffusion layers. Yeah, so we have seen what exactly mean by p-type. So directly start with, I will start with the application of this one. So in the p-and is used as photodetector for the most fiber optic communication. So photo detector, where is there? So it is act as a photo detector. The pin diode we can have it as a photo detector. They are also used in the electronic preamplifier to boost the sensitivity. If you want to boost the sensitivity, then you can use the pin diode. Then they are used as the variable resistor in the RF and micro frequency. Means you can use as it is as variable resistor itself. Then why is it used in the RF modulator circuit? To control RF intermodulation distortion. If you want to control the RF distortion, okay, RF intermodular distortion, then you can use as RF modular circuit itself. Likewise, you can use this as phase shifter circuit. Okay, phase shifter circuit, and pin diode is also utilized as just a minute, series or shunt connected switches. Means we have discussed in this previously, that is nothing but Suppose just a minute, I will drop this portion. Okay, I will click pen. Okay, so we have discussed this thing. Suppose I will draw once again over here. Suppose this is my dielectric material, it will not conduct, and here is the two metal plates are there, and we have discussed that frequency is directly proportional to my, what you can say, distance. We said distance between these two plates, so if my distance is going to increasing, the frequency is also going to increasing. If my distance again going to increasing, my frequency also going. But how we are maintaining this distance, because this is a capacitor, so we can't change the distance in between that. But what will happen, the distance it totally depend upon whatever the potential we are giving at the this terminal. Okay, and we have to apply a negative voltage across that one. So if we are applying more and more negative terminal, then the distance between these two intrinsic layer will get increasing, and we are obtaining the higher and higher frequency. Okay, if you are decreasing the distance, the frequency will also decreasing when you are getting the less frequency. So you can act as a to tune the different frequencies, lower frequency to high frequency. We are applying less negative voltage, so the frequency will be less. If you are applying less voltage, so frequency will be less. If you are applying more voltage, negative voltage, then frequency will be more, like this one. So these are the application we have seen. So in the today's lecture, we'll see about the GUNN diode. Okay, in today's lecture, just I will drop this portion. Okay, in today's lecture, we will see the GUNN diode. Okay, so what exactly mean by GUNN diode? So just GUNN diode is that the GUNN diode, it operates on the, it's we can say that it is nothing but a transferred electronic device. The electrons are transferred over here. So in this lecture, what we will see, I will just go through it. Okay, we will see the construction of this one, what exactly is GUNN diode construction, how it looks, then what exactly mean by GUNN effect. Based on this GUNN effect, the GUNN diode works. Then what exactly mean by GUNN diode oscillator, then GUNN diodes working. Okay, then GUNN characteristics, and some of the GUNN diode application we will see in this lecture. So we'll start with this. So what exactly mean by GUNN diode? So GUNN diode is nothing but just it's what you can say, normal pin diode, normal diode itself. But normal diode, PN junction diode, it's having two junctions. It's having two junctions, but in this diode you will just find one semiconductor only. That is nothing but the N type material only. Just one semiconductor material is N type material is there. In this one we are using GAS. Okay, GAS. GAS means what? Gallium arsenide. Gallium arsenide. So we are using GAS over here. So GAS we are using. So this, it's not like a normal PN junction diode. Here we are using GAS, but in the negative material. But we are adding a more kind of impurities in this one. But what will happen with this? If you are applying more and more voltages, okay, more and more voltages, then what will happen? The at certain voltage, electrons will get flow, and after that, electrons start to resist the thing, and due to which phenomena called as negative differential resistance will happen, and due to which a circuit will oscillate, and which generate that microwave frequencies. Means what exactly? The GUNN diode, if you are applying and more voltages, then what will happen? The GUNN effect will cause, and that, and it will act as a oscillator. That we have to see. Yeah, over here. It consists of only N-type semiconductor we have discussed, in which electrons are majority charge carriers. To generate a short radio with such a microwave, it utilizes GUNN effect. So the term is GUNN effect. We will see over here in the next slides. So this is a GUNN diode over here. So which we can use it for to generate a microwave frequency. Okay, we can generate a microwave frequency. If you are applying just voltage, it generates a microwave frequency. So we know that amplifier, amplifier and oscillator are the two terms. Can you differentiate these two terms? Can you define one difference in between this? So give me the just one difference in the chat box. I will watching your comment. So your time start now. I will wait for 5 to 10 seconds in which you have to give me the answer as what is the main difference between amplifier and oscillator. Just start. Okay. Just give me the answer. What is the difference between amplifier and oscillator? Just one difference. Okay. Okay, let. So what exactly mean by gun effect? So gun effect, it was invented by John Gunn in 1960 after the experiment on GS, gallium arsenide. He observed a noise in his experiment result and owed this to generation of electric oscillation at the micro frequency by steady electric field with the magnitude greater than the threshold voltage. What exactly mean by? What exactly mean by? Suppose the threshold voltage, what exactly mean by threshold voltage? That if you are applying suppose 50 voltage is the threshold voltage of any diode, threshold voltage of any diode 50 volts. So below that the diode will act as normal diode. Diode will act as normal. But after that the diode, the electron will start to scatter, and it will not allow to flow, and which forms a negative region. That's why what will happen, electron will not flow and they start to oscillate, and due to which we are getting the microwave frequency. Okay. The Gunn effect can be defined as the generation of microwave power with the microfrequency around few gigahertz wherever the voltage applied to semiconductor device exceeds the critical voltage value of threshold voltage. Means we are applying a threshold voltage greater than that, then whatever the effect is called as Gunn effect due to the oscillations of electrons. Yeah, Gunn diode as oscillator. So Gunn diodes are used to build oscillator for generating microfrequency ranging from, just keep in mind what is the range, 10 gigahertz to terahertz. So tera is nothing but what, 10 raised to 12, 10 raised to 12. So this frequency is generated by what, this Gundard oscillator. With we have to apply some kind of voltage that is nothing but the DC bias voltage itself. Okay. And due to this the total differential resistance of the circuit becomes zero. Okay, what I exactly mean by, so diode will give you a negative resistance regions, and whatever the voltage that is the DC bias voltage we are applying, that is a positive voltage. So that's why what will happen, the negative resistance of diode cancel with the positive resistance of the circuit, resulting in the generation of oscillation. This will generate an oscillation. Okay, so the gun diodes working. This diode is made up of single piece of n-type metal that we have discussed. Previous slide I have showed you that the n-type semiconductors such as gallium arsenide or indium phosphate. Indium phosphate is also there. So can you give me the where we are using indium phosphate? Indium phosphate. So I will give you the answer that you can use this in the LEDs. LED, whatever the LEDs are there, that we can develop by using indium phosphate because it will having more current capability. So whatever that large watt LEDs are there, like 10 watt LED is there, okay, 10 watt LED is there. So whatever this diode is there, we are using LED, that is nothing but gallium indium phosphate. Sorry. GS and some other semiconductor metal have one extra energy band in the electronic band structure instead of only having two energy bands, that is valence band and conduction band, like normal semiconductor. Okay, I'll explain this thing. Just a minute, I will drop this portion. Okay, just a minute. Yeah. we know that there are two bands out there as per a semiconductor is concerned. So this is one band, this is the second band. So last orbit is valence band, I will write as valence band. Okay, and this is the my conduction band. In between these two, we say that this is nothing but the forbidden energy gap over here. Here electron will not stay over here. Either electron will stay in the valence band or either it will stay in the conduction band. Okay, so in the normal material like germanium or silicon, these two bands are occur. That is nothing but the valence band and conduction. But in the GAS or indium phosphate, you will find a third band. Okay, third band, this third band is empty and in initial stage. Okay, so whatever the energy band is there, that is nothing but the third band. Some kind of over here you will find energy band over here, but this is my empty band over here. And if you are applying voltage to this device, the most of applied voltage appears across the active region. The electron from the conduction band having negligible electrical resistance are transferred into the third band because these electrons are scattering by the applied voltage. So what will happen in this case? So I will rub this portion again. Okay. So suppose this is the structure. Okay, this is nothing but my valence band. This is nothing but my conduction. Normally we are having this thing. Okay, instead of here I have to draw over here. In the last image I have drawn over here below, but actually that is wrong one. This is the correct. Here you will not get it. So if we are applying some kind of voltage, so electron will jump from valence band to conduction band over here. And if you are applying more and more voltage, then electron will jump from this conduction band to the empty band over here. Over here this will jump and they are going to be scattered. Okay, they are going to be scattered, and due to the scattering negative resistance will occur, and the whatever the effect is called as oscillation effect, and we are getting the micro frequency. Okay, so what will happen? Electrons are at the valence band, they are, if you are applying the voltage, then it will go to conduction band. And what will happen with the conduction band? If you are again, if you are applying more and more voltage, then the threshold voltage, then it will go to the third stage, and here they are getting scattered, and due to scattering what will happen? Negative resistance will occur and the oscillation starts. So today we will stop over here. So thank you very much for attending this lecture. Thank you.